All right, going on to section B for chapter 14 worksheet. So looking at numbers 1 and 2. So first part, number 1 says sketch a graph. So they give us some specifics on this. It says to use millimeter square paper, which is the IB graph paper, and a scale of 2 centimeters per unit on each axis. So wanted to show you what that looks like. And I have IB graph paper on the website if you ever want to print it and practice with it. But here's what this is all going to end up looking like. So this is the IB graph paper. It's like this full sheet of all these tiny green lines. So when they say, and that's why they call it millimeter graph paper, that's what this is called. This is what they give you on the IB test. When they refer to 1 centimeter, if you kind of notice, every fifth line is a little bit darker. Those are centimeters. So if you actually held up a ruler to that, you would see that those guys represent centimeters on those. So that's 1 centimeter, 2 centimeters, 3 centimeters. So every centimeter, which is every fifth line, is a little bit darker, so you can kind of help separate out what's what on there. So for this one, they're giving us this graph to sketch, and obviously there's, this is not your typical graph. This is something that would be done in a calculator. They're giving us a domain. We only sketch from -4 to 4. And then we got to stick with our axis scale that they're telling us right here. When you're doing the IB test, really important that you label everything. So when you do it on IB graph paper like this, you can put your graph anywhere on the page. So I just chose to draw my lines, where you can see them on here. Let me see if I can show you the full sketch. So that's what the whole thing's going to look like. So I just chose to put my axes somewhere in the middle. But notice I labeled the axes exactly how they said to label it. So let me go back to this. So they said 2 centimeters is 1 unit for this problem. So that's what you're seeing. So I went up 2 centimeters to get 1 unit. I went right 2 centimeters to get 1 unit. So there's the scale. This would all really be done in a calculator to get all this information. So what I did was I would go right to the calculator. Let's go to the graph. This one had pi in it, so I know I should be in degrees. So let's make that change. So if we plot the graph that they're giving us, so x minus pi sine x. So there's our graph. One thing to consider is the window on this graph. They give us a domain from -4 to 4, so that's really all I want to look at. So I'm going to go to my window, and I'm going to change my x to -4 and my x max to +4. I may need to adjust my y's. We'll see if I need to in a minute here, but when I hit graph, so this is the graph I should be sketching on my page. In order to get accurate points on my grid, I would go right here under table, so second table, and I'm just going to pick points right off of there. It said to start at -4, so this would be the first point that I would plot, so -4, -6.4, and then I would just move on to the next one. So I literally took the points from -4 to 4 and plotted those points on my graph to make sure I had a good graph. So if I were taking the IB test, that's the way I would handle it. And that's where I came up with the graph that you're seeing on here. So I just plotted those points right off the table of my calculator. A few things that they ask you to get are identify a max and a min. The x-intercepts, you got 3 of those. So they ask you to label all that stuff. So if that were the directions on an IB test, you got to make sure you follow those directions and do exactly what they say. So that's what I did on my graph. You do use pen on the IB test, so if you ever make a mistake like I did here, just cross it out with an X, and they kind of understand what that means. So I'll just show you really quick if we wanted to get some specifics on this. For example, if I want the intercepts like this one here, if I go under calc, so second calc, intercepts are zeros. So if I choose 0, there are 3 of them, so I would have to find all 3 individually. So let me just put my cursor closest to the one I want to find first, which is right about there. My my calculator wants me to give it a left boundary, so if I'm just going to go left a couple times and hit enter, and then a right boundary, so I should be to the right of my intercept a few times and hit enter, and you'll see the window kind of closing in on the answer I'm looking for. So now when it says guess, I just hit enter, and down there at the bottom it tells me that x-intercept, and so that's what I labeled on the graph right there. And again, I could just do, obviously that one's at 0, 0, but I could do that same process again for this guy if I wanted to label both, and that's how I came up with him. As far as a max or a min, you can see there's a max right there, so if I go under calc and choose max, so again, I know the max is right about there, but they want me to give it a left boundary, so I'm going to go to the left a little bit and hit enter. A right boundary, so I should be to the right of the max and hit enter. So that sets up the window, so now it's going to find the max in that little window. So now if I hit enter one more time, it gives me the exact coordinates of that point. And so that's what I wrote right here on my graph to identify the max. You could repeat, do the exact same process, but when you go under calc, for the next one, just choose minimum and then do the exact same thing to get the coordinates for that point right there. So anyway, calculator can do all those things for us, and so that's what I got from my graph and how I did that one. Moving on. So find a solution to the equation. So for this whole thing to equal 0, all you have to recognize on that is the solution to the equation those are x-intercepts. So, those are x-intercepts. So if you look at your graph, there are 3 solutions to that equation. This guy, and this guy. So that's why they then specifically say, give us the one that is negative. Give us the one that is less than 0. So there's only one of those on the graph. So that's the negative 2.3. And I already rounded it to 2 sig figs, which is what they said to do. So that would be that answer. Now we're getting into, for the next part, the integrating part of this. Let me slide down a little bit. So just want the indefinite integral for this guy. So whenever you got the minus sign right there, we just split up the 2 terms. So if I were to integrate just the x, that would become x squared over 2. And then the pi can stay. Integral of sine, we know is negative cosine. And so that would be our indefinite integral. So it's indefinite, so we got to throw in the plus c, otherwise you get marked down for that. And of course we have the double negative, so we could write that as a positive. So we could write the 1/2 x squared plus pi cosine x plus c. So part D, now the last part, hence or otherwise find the area under the region enclosed by the graph, so on and so on and so on. So I think they should have included one more piece of information on that. It says the area of the region enclosed by the graph, the x-axis, and the line x equals negative 2. So here's the x-axis, obviously here's the graph, here's the line where x equals negative 2. So they must be referring to this area right here. So I think the phrase enclosed by the graph would stop you at this point instead of continuing on to this area as well. So maybe that's implied. It would have helped if they would have said not only where x equals negative 2, but also where x equals 0. So that would have been a nice cutoff at the right, but I think it's kind of implied on this one, just to write the idea of the area enclosed by the graph. So anyway, so we can see that we need to use the integral and evaluate it from negative 2 to 0. So we're going to take our integral function right here, and it's no longer going to be indefinite, because now we're going to do it from specific points. We're going from negative 2 to 0 of our function. So that's what we're going to do on this. For this one, we can do this in our calculator as well. So I could plug in my -2, I could plug in my 0, I could solve that by hand. Nothing wrong with that. But since we already have the graph on the calculator, it would only make sense to use it and take advantage of it. So if I go under Calc and go down to option 7 where you see the integral of the function, so if I hit enter, it's going to say what's your lower limit. Remember, we're going from -2 to 0, so my lower limit is -2. So I'm just going to hit -2, enter, and that's going to say what's your upper limit. And remember, our upper limit's at 0, so I'm just going to hit 0, enter, and there it goes. It's not only shades it for me, but it also gives me the answer. So from -2 to 0, that area would be about 2.45. would be the area under that curve. So that's a great thing to take advantage of. Obviously, this was a calculator level question anyway, so definitely something we would want to take advantage of for that. All right, moving on to number 2. So last one. So up here we're given an acceleration function where t represents seconds. So given that the initial velocity is 4, so find the velocity. So one thing we got to recognize on this is that we would need to integrate this in order to get velocity. So remember, acceleration is always the derivative of velocity, so we're going backwards on this one. I got to integrate to get up to velocity. And they're also going to give us some information so that instead of an indefinite integral, we're going to be able to solve for c and actually get a value for that. So if we go kind of down the line and integrate this, this would become 4t squared over 2. And obviously the 4 over 2 just becomes 2. So I'm just going to be looking at t squared over 2. For the sine, integral of sine is negative cosine. And then for now we're going to put a plus c, but that's something we can solve for given this information right here. So when they say initial velocity, that's an important phrase right there. Initial means at the start, which means for this guy, time is 0. So I'm going to plug in a 0 for time, and the velocity is 4, so I got a 4 right there. If I put a 0 here, that becomes 0. The cosine of 0, so remember at 0, that's at the point 1, 0. Cosine is the x, so that value is 1, so it was 0 minus 1 plus c. So if I just add that 1 over to the left, we now have a value for c that we can sub in and use from here. So if we were, let's just kind of put it all together here so we can work a little farther. So right now we know that our velocity function is our 1/2 t squared minus cosine t plus 5. So part B then says integrate that. So they want us to integrate the velocity function and evaluate it from 0 to 5. And they're giving us a specific form on how to write our answers, so definitely something we'll take into account. So we're going to integrate this guy from 0 to 5. So going on down the list, we would have, this would become t to the third over 3, so that becomes 1/6 t to the third. The integral of cosine is sine, so this just becomes minus sine of t plus 5t to the first over 1, so 5t to the first. So there we go, we have our function. We got to evaluate it for a couple numbers here. So if I started with the 5, we're going to see 1/6, 5 to the third, minus the sine of 5, plus 5 times 5. So they want me to give it in this format right here, so let's simplify a little bit here. 5 to the third would be 125. 125 divided by 6. Which doesn't go in really evenly, so my guess is, and I'm looking at their worked out solutions, I don't know if they initially intended for this to be a 6 instead of a 5, because that would have been a prettier number, but this says 5, so we're going to keep going on that. So I got my 125 over 6. I need to add 25 to that. So I'm going to add 25 to that, and I'm going to write that as a fraction. So I'm going to hit math, fraction, enter. So 275 over 6. Minus sine 5. If we plug in the 0, you're going to get 0 for everything. So it would just be this minus 0, which is just this. So that would be my answer, and that's technically in the form that they said to write it in. Looks like they were intending for that to be a 5, so we did it right, even though the worked out solutions are kind of using a 6, which probably would have made more sense anyway, but that's what this one said to do. So interpret our answer. So all they're really looking for on this one is simply this represents displacement, or the distance traveled from 0 to 5 seconds. Keep in mind that when you integrate velocity, you get distance or displacement, so that's what they want you to recognize. And so we would just say something along those lines about this representing displacement or the distance traveled in the first 5 seconds is what that would tell us. So that's it.